Hello, everyone, and welcome to our video for our most missed quiz questions. This video is specific to our first quiz for Algebra 1, and hopefully this is helpful to you in just sort of getting a better understanding of some of the questions that you may have missed, and also give you an opportunity to study for your upcoming test. So in this video, you're going to notice it's a little bit strange the way that I have this set up because I'm using Google Meets to do this recording. And so there's going to be a little bit of back and forth, but I think that's okay. So I'm going to go ahead and share my screen. We'll get going. All right, so one of the most missed questions in our quiz was question number 4. And so your screen looked something similar to what I'm seeing now because I'm previewing as a student. And so in this question, it asked for you to explain why table A is a function and why table B is not a function. And one thing that I saw happen quite a few times was students would tell me in their response window would say table A is a function and table B is not a function. And while that is true, that's also already stated in the question. Like the reason why we're giving that to you is because we want you to give us an explanation as to why this is the case that table A is a function and table B is not a function. Something fairly common that came up is I saw that some people even would try to say that table A was not a function because it had negative numbers. Whether or not something is a function does not depend on whether or not we have negative numbers or positive numbers. The other thing too that a lot of people tried to say was that if you look at table A, for instance, you'll notice that table A does not have a constant rate of change throughout. And so because of that, this table is not linear. And so there were also some people that sort of got confused this idea of what's a function and what's something that would be a linear function, because table A does not represent a linear function, but it does represent a function. Now, when I look at table B and table A, there's, other than maybe, the fact that the Y's are all negative over here, the biggest difference that I notice is that table B has repeated inputs. So repeated X values. And so you'll notice that if we have an input in this table of 2, I'm either going to get 7 or I'm going to get 8. And that, by definition of a function, is not going to be a function. So with a function, every input has exactly one output, okay? In this case, we see that this input of 2 has 2 outputs. So it has multiple outputs, which is not going to give us a function. Now, if you were to put this on a graph, it might even become more clear, because if you were to try to use our vertical line test, this table, if you were to plot these points, would not pass the vertical line test because the points 2, 7 and 2, 8 are going to be stationed on top of one another. And so that is why table B is not a function, is because of the repeated input values. All righty, on to the next one. The next set of questions that was mostly missed was this slide number 4. And this question was talking about reasonable inputs and outputs, and the idea of inputs and outputs. And if you are still confused about this idea after watching this video, I'm going to ask you to go back and watch the 1.2 ed puzzle that we assigned, because that is all about this idea of inputs and outputs. And I think that would be really helpful into giving you a better understanding of how this question could be responded to. So this question says, a dog owner buys a 28-pound bag of dog food for their 2 dogs. Each day, the dog owner uses 1.75 pounds of food. So in this problem, we need to decide what are the inputs and what are the outputs. So we can almost think of this as being a linear function, actually, because the rate of change at which the dog food is being used is the same every single day. And so we start out with 28. And we're going to be using the 1.75 pounds of food every day. So what represents the inputs? What represents the outputs? Some people told me here in this problem that the inputs was the 1.75 pounds of dog food. And that isn't the inputs. The inputs are actually the days, because as each day passes, we're getting less and less food, right? And so the input, the representation for our inputs, is going to be the number of days, And then we need to decide, well, what represents our outputs? So as I plug in 1 day, 2 days, 3 days into my linear function here, what's going to happen? Well, each day I'm going to have less and less dog food, right? But the output value that I get is telling me how much food in the dog food bag is left, right? And so what we can say, and this is one way to word it, but you may have worded it differently. The way that I worded it here was it's the amount of dog food that's left in the bag. Okay, so as we plug this into our function and see sort of what's happening, we're going to see how much dog food is left after each iteration. And I'm going to show you what kind of function I think we could make out of, or linear equation we could make out of this situation. So the next part, and this was a part that really tripped up almost every single student, was what would be a list of reasonable input values and a reasonable list for the output values. And this idea is basically what numbers would we cross through as we go from having no days and 28 pounds of food in the bag all the way to the point where we have no food left in the bag. Okay, so how many inputs could I go through before I get to that point? And how many outputs could I get before I get to that point? Okay, and so what we'll do, and I'm going to show this part first, and I would not type this into the list here. I'm just going to type this in because I don't have a drawing pad to show this to you. So the function that would work for this, or the linear equation that you could write for this specific problem, would be f of x equals negative 1.75x plus 28. And again, this isn't the answer that goes here. I'm just using this text box to show you this is the type of function that we would be using to solve this problem, okay? And so you'll notice that if I were to have an input of 0, so if I were to say f of 0, 0 is a possible input value for this problem, because if I plug in 0, what am I left with? Well, this would go away and I'd be left with 28. So with the input of 0, my output value is 28. No, this is negative, sorry. If I have f of 0, if I plug in 0 for my input, my output is 28. And so now I have an input and an output that both are going to work in this setting. And then what we're going to do is we're going to keep going through this process. And we'll see that as I continue to add new inputs into this, I'm going to get more outputs. So what I'm going to do now is I'm going to actually close out of this screen so that you can see what are the list of reasonable input values. And basically what you're going to do is you're going to start at 28. So 28 would be our first output. And then as I put in f of 1, so I input 1 into the function, now I have negative 1.75 times 1 plus 28. And so basically what we're going to do is for all of our outputs are going to be 28 minus 1.75, and then my next input I plug in would be 2, so I'd minus another 1.75 from what I just had. And you're going to continue to minus 1.75 until you can't minus it anymore, okay? And so however many times you had to minus 1.75 to get to 0, that's going to be the number of inputs that you had, and all of the results that you got, all of the individual outputs you got are going to be your reasonable outputs. So what I'm going to do is I'm going to actually show you what our answer key said here so that you can see this. So the reasonable input value, so this is how many times you're going to go through and subtract 1.75. So we start with 0 because after 0 days, the dog owner doesn't use any of the dog food. After 1 day, they use 1.75 pounds and they're left with 26.25 pounds. And you continue to subtract all the way until you get, it looks like in this case, there were essentially 16 days that we are going to be able to go through this 28-pound bag of dog food. In question 9, you'll see that the reasonable output values are all of the intermediate steps where you're subtracting 1.75. So we start with 28 pounds of dog food. We minus 1.75. That gives us 26.25. Then we minus 1.75 again. So on the second day, we're going to have 24.5 pounds. And then we minus 1.75 again. And we keep doing that. And notice you'll see we have 22.75, 21, 19.25, 17.5, 15.75, 14, 12.25, 10.5, 8.75, 7, 5.25, 3.5, 1.75, and then 0. Okay, so those are all the reasonable output values, are all of the possible output values that we could have in a given situation. And all of the possible input values are all of the possible, or all the reasonable inputs are all of the possible input values we could have in a given situation. So by the time the dog owner runs out of dog food, there's none left. That's going to have been 16 days. And that's why I know that all of my inputs are going to go all the way up to 16. So that's how we would answer that question. I'm going to go back to my student preview here. The last question that I really want to talk about here, and actually I'm going to talk about slide 6 and slide 7 here. So numbers 12 and 13. So number 12, so this one was worth 4 points. So if you missed this one, it definitely hurt your quiz score. So this one's nice because I actually have to show your workbox. So I'm going to get to draw on this, which will hopefully be helpful for you. What you had to do here is you had to put your age as the input value into this function. And the input value is always going to be the X value. And many of you are, and this says put your age in there. Many of you are 14 or 15. For this example, I'm going to go ahead and use 14. So what I'm going to do is I'm going to replace my inputs. I'm going to replace my X values with this input of 14. So I'll say F of 14 equals 2.5 times 14 minus 11. Okay. And so now what I need to do is say, all right, now that I've used my input of 14, what I need to do is I need to go ahead and simplify this now. So I see now on the right side here, I have 2.5 times 14 minus 11. So if you plug 2.5 times 14 into your calculator, you're going to get something that looks like this. And again, we still have F of 14 on the left-hand side. 2.5 times 14 is 35. And so we're going to have 35 minus 11. And again, we're going to say, well, we can still simplify this. And so again, we still have F of 14. So F of 14 is like our Y value, it's our output. So the output at 14 equals 35 minus 11, and 35 minus 11 is 24. So this is how you would do a problem like this. Now, let's say, let's go ahead and use a different example, but same idea. Let's say you're 15. So you want to go ahead and use your age is 15 as the input value. Literally the only thing that we end up changing about this when we go back is we're just changing the input values, right? And so you'll do the same exact process. You get through this, you're plugging in 15 now into the equation if you're 15, and we would still say F of 15 And then we'd say equals, and so let's see, 15 times 2 is 30, and half of 15 is 7.5. So this would be 37.5, I believe, minus 11. And again, it's the same idea, guys. So then we get to here, and 37.5 minus 11, that would give me that f of 15 equals 26.5. So people may have had different answers here, and that's okay because we're going through and we're checking all of these. So that's how you would answer question number 6. All right, last but not least for our video here, we're going to talk about number 7. And that was trying to determine, is this table something that is linear or nonlinear? Is this linear or nonlinear? So let's go ahead and take a look. So something that is linear, okay, so again, we're not asking about whether or not, because some people said this, they said, oh, this is a function or this is not a function. That's not what the question is asking you, because again, functions can be linear or nonlinear. So we're not asking you whether or not this is a function. We're asking you if this table represents a relationship that is linear or nonlinear. So what I'm going to do is, to know if something's linear, I'm going to look at the output values. So I'm going to look at these y values here. I'm going to say, because the x values, they're moving up by 1 every time. I'm not concerned about anything funky going on over here. But even if those values were going by 2s or by 3s, as long as they're going by the same values each time, it's okay, assuming that the y values are going by the same value each time. So I notice here I go from 9 to 8. So I minus 1 to get to here. I minus 1 again to get to here. I minus 1 again to get from 7 to 6. But then all of a sudden, the pattern changes. And in the next iteration, I have to add 1 to get back to 7. In that situation right there, the fact that we've now changed the pattern makes this non-linear. So this is not going to be a linear table, because linear relationships, the output values are always going by the same number each time. And so in this case, we see that right at the very end, that pattern is being changed. So this is going to be a situation where we have something that is non-linear. So those are the questions that were most missed. And if you are someone that is still struggling with some of these ideas, I'm really going to encourage you to come to your teacher's office hours, whether that's myself, Ms. Rowland, Mrs. Jench, or Mr. Anders. We are all ready to help you. And again, we have office hours at least twice a week. And then if you count Wednesday as well, that's 3 times a week. If you want to make an appointment with us, you can do that as well. But there are these options that you have to be able to come in and get help, and we're ready to help you. So I hope that you found that this video was helpful for you in sort of getting a better grasp on some of these ideas, and good luck on your studying.